Perhaps this is the second part of this double lesson, and now we're going to do questions that involve triangles and quadrilateral. Triangle, you know what a triangle is, three sides. Quadrilateral, it has four. Okay, so we're going to add a couple of more properties, reasons, but let's do it through the question and not just in theory. Okay. So I'm at page 179, question F. Okay, so we've got this triangle. I know these two lines are parallel, BC and EF, and I'm told that this is 2A, ATB, and this is 5A minus 40. We'll call that, no, I don't need to call it. Now, what we are asked to find is A, right? Find out A. And then they ask us to prove that AF is equal to AE. Okay? So I'm just going to make sure, I'm going to make sure that I've got everything right there. Okay. So, yeah, we want to find out A and then prove that this triangle is, the sides are equal. Okay? Okay. So how are we going to do that? We're going to try and find out A. Now, there's a quick way and a long way. I'll start with the long way, which is maybe easier, and then the quick way, which we also going to need to know. Okay, so first thing, I want to find out what B is. You'll see in a minute why I want to do it. But how do I know what, well, I don't want to find out what B is, but I want to express this in terms of A. What do I mean? Look at these two angles. We'll call that A1 and A2. Okay? I know that A1 plus A2 must be equal to 180. Why is that? Why they must be equal to 180? Because these are adjacent angles on a line. Okay? So, therefore, I can say, okay, 5A minus 40 plus B, because this we know is B, okay, is equal to 180. Now, I can't solve B here, but I can express it in terms of A. You'll see why that's useful in a minute. So what I'm going to do, I'm going to leave B on this side and move everything else to the other side. But let's do it in steps. So first I'll move the 5A. So it's going to be B minus 40 equal 180 minus 5A. Just did minus 5A. Now I'm going to get rid of the 40, so I'm going to say B plus 40. Okay? Here I did minus 5A. So plus 40 will be 220 minus 5A. Okay, so now I know B is 220 minus 5A. Now I'm looking at this triangle. Okay, in triangle AEF. Okay, this is the first thing we're remembering today, is that the sum of angles in a triangle must be equal to, correct, 180. So I'm going to say, okay, B. What is B? Instead of B, I'm going to write 220 minus 5A, because I just found what B is in terms of A. So 220 minus 5A plus 80, plus 2A, that has to be equal to 180. And why? Okay, and this is the new thing we're learning. Sum of angles in a triangle. Okay, sum of angles in a triangle has to add up to 180. So then I'm writing all this. 80 plus 220 is 300. Minus 3A, minus 5 plus 2A is minus 3A, equal 180. I'll move the 300 to the other side. I'll have minus 3A equal minus 120, divided by minus 3, so I get rid of 3 and the minus. I get A equal 60. Now, is that right? I think I might have got something wrong. No. Sorry. It should be 40, isn't it? I think I might have made a mistake. Just to hang on for a second. Yeah, all good. So it's not 60, obviously, it's 40. Okay, so A is 40. How does that help me, though, to prove that AE is equal to AF? So this is the second thing we're learning here. I know here that this angle is 2A. We'll call it E1. Put 2A, I'll put E1. Therefore, E1, which is 2A, is going to be equal to 80. So, these two angles are equal. Okay? And if the two angles are equal, that means the two sides are equal. So I'm going to write, therefore, AF, can you see that? Yeah? AF is equal to AE. And the reason, this is the second thing you need to remember, the second thing it's kind of needed for us, is that we've got, I'm just going to make sure I write it right, equal sign, second, hang on with me, sides opposite equal. So side opposite equal angles, okay? So if the angles are equal in a triangle, then the sides are equal, okay? Sides opposite equal angles. We prove that the angles are equal, therefore the sides are equal. I'm just going to pause here for a minute. Okay, so I told you this is the long way, which is maybe the easier or not the easier, I'm not sure. But I'll show you the quicker way. Okay? So here, what did we do? First of all, we expressed B in terms of A. So we found what B is, because they together have to add to 180. But if you remember there's one more property, it will make your life much easier. You can say that this 5A minus 40 is equal to sum of these two angles, 2A plus 80. Okay, let me explain. So this angle, which is actually outside, exterior to this triangle, this angle is equal to the sum of these two angles. And the property is, this is called an exterior angle, and it will be equal to the sum of the opposite angle, or sum of the angles opposite to the interior angles. Okay, if this is the exterior angle, it's on the outside. This is the interior angles, it's the angle on the inside of the triangle. These two angles are opposite to the interior. So the exterior angle is equal to the sum of the opposite to the interior angle. Let's just write that down. Okay, so I'll wrote it down here. Exterior angle equal to the sum of interior opposite angle. This is the exterior angle. It's outside the triangle. Is equal to the sum of the opposite interior angle. Now that will help you straight away, because now you can find straight away what A is. Okay? If you use this equation, you will find out that A is equal to 40. So you see, by saying that, you're skipping all of this line. So as I said, it's quicker. But you got to remember this extra property, exterior angle, this is the exterior angle, is equal to the sum of the opposite interior angle. Let's move on to another question. Okay, the next question is to do with quadrilateral. Okay? Four sides. So we told that ABCD is a parallelogram. Now, what is a parallelogram? Parallelogram is a quadrilateral with two pairs of parallel lines. In other words, BC is parallel to AD, and AB is parallel to CD. Okay, that's what the parallelogram is. Okay, has to be two pairs of parallel lines. And what we asked to find is D1, D2, I think. Where, by the way, this is question I. Okay, on the same page. So D1, D2, and B2, B3. Okay, let's start with D1. Okay. Now, by the way, they're giving us this line. This means that it's 90 degrees. So we know that B1 is 90 degrees. So I'll start by saying that 70 plus 90 plus D1 will be equal to 180. Right? Because that's sum of angles in a triangle. Sum of angles in a triangle. So quickly, I'll just do it quick. This is 70 plus 90 is 160. So D1 is 20. Okay? So this is 20. Okay? Now, I can straight away find out what D2 is. Why? Because D2 plus, or let's put it this way. Let's put it like this. Yeah. D2 plus 20, this angle, plus this angle, plus 70, must be equal to 180. Why is that? Why these two angles must be equal to 180? They are co-interior angles. Co-interior angles. And which parallel lines? It's DC and AB. I know the that DC is parallel to AB? Because it's a parallelogram. Okay? So I can again very quickly find out this is 90. I know that D2 is equal 90. Okay, so I've got two of the angles that I wanted. I'm just being asked to find D1, D2 and B2, B3. Okay, B2. B2, I can straight away say that B2 is equal to 20. Okay, why is that? These two are alternating angles equal, and which lines are parallel? AD parallel to BC. So I've got that as 20. Okay? Now we want to find out B3. There's a couple ways I can do it. I think I'm just going to go straight away and say B3. I'm going to be cheeky. Yeah? Straight away say that B3 is equal to 70. Okay? Why that? Because these two are corresponding angles. So corresponding angles, which pair of lines? Again, AD parallel to BC. Okay, so I found all the angles that I've been asked to. Now, if you look at the question, what they ask you to do is prove that BECD is a parallelogram. I want to prove that it's a parallelogram. I know that this is 70. Okay? I know that this is 20. Okay? What else I want to know? Okay, so I can do that one. Okay, and D2, sorry, D2 I found is 90. Is that right? Okay, so I want to show that. I'm just going to pause you for a second. So now they're telling me that this shape, this quadrilateral, I want to prove that parallelogram. So in other words, I need to prove that there's two lines that are parallel to each other. Okay? Now, I already know that this line is parallel to that. Why? Because this is parallel to that. So this is just a straight line. So that is parallel to that. So I can already say that DC is parallel to AE. Okay? And that is because, why are they parallel? Because ABCD is a parallelogram. You see, I know that these two are parallel, so that means this is the same line. So these two are parallel. Okay? So I just want to show that these two are parallel. Okay? But look at this. This is 20, and this was giving us 20. Okay? So I'm going to call that B2, and that's already given C1. So I'll write B2 is equal to C1. Okay? It's equal to 20. I showed that. Okay? So proved. I need to say it's proved. I can't just say it. I've proved it already. I found that the C1 is, B2 is 20. So I need to say proved. Therefore, okay, I can say that BD is parallel to EC. And why is that? Because alternating angles are equal. Okay, I've proved that the alternating angles are equal. Therefore, the lines are parallel, and therefore, I can say that EBDC, can you guys still see it? Not really. So we're going to write it here. Therefore, BECD is a parallelogram. Okay? Has two pairs of parallel lines, it's a parallelogram. Let's move on. The last question they want to tell me, I want to prove that this parallelogram is in fact a rectangle. But that is really dead easy. Because look at B2 and B3. Okay? Angle B2 plus B3 is 20 plus 70. It's 90 degrees. So I've got a parallelogram with an interior angle of 90 degrees. Okay? If a parallelogram has an interior angle of 90 degrees, then it's a rectangle. So I can just say BECD is a rectangle, and the reason, running out of memory here, carry on, it's a rectangle because interior angle is equal 90. If this is 90, then think about it. That will also be 90 because they are co-interior, so that must be 90. And therefore that is 90, therefore 90. And that's what a rectangle is. A rectangle is a parallelogram with the interior angles of 90. Okay, I'm going to do one more video for another example.